Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture for August 24th of 2025 is titled The Spinning Pulsar of the Crab Nebula. So what do we see here? Well, here we're looking at the central region of what is known as the Crab Nebula. Now, this is a supernova remnant and was actually seen to explode as a supernova here on Earth back in the year 1054, nearly 1,000 years ago. And that's actually been recorded in various historical records that a new star appeared in the sky at the location that now contains the Crab Nebula. Now, a supernova like this is called a Type 2 supernova and happens at the end of the life of a massive star. At that point, the star builds up a core of iron which becomes unstable because you cannot get any energy from fusing iron together. And when the core gets hot enough, the iron fuses anyway, but it takes energy and eventually causes the star to implode and then eventually rebound outward as a supernova that we can see in the sky. That material then expels outward, but the collapsed core of the star is the bright dot at the center here. And that is what is known as a neutron star. And it gets that name because it is so tightly packed that the electrons have been pushed into the nucleus where they combine with protons, essentially making a big ball of neutrons. So this small object, about the size of a city, a few kilometers across, is more massive than our entire sun. And that's because we've squeezed out all the space within the atoms, and that pushes material as close as it can possibly be by our understanding. So pushing it any farther down would make it a black hole, and a neutron star is just at the edge there. It's not quite a black hole, but it's very close. Now, the neutron star, when seen to be spinning, can become a pulsar. And that means we get bright beams of light from it, which can be visible light, but also things like X-rays and radio waves. And in fact, the image that we're looking at here has a combination of three different lights that we're looking at, three different types of light. And that's optical from the Hubble Space Telescope, as well as X-ray from the Chandra Observatory and infrared from the Spitzer Space Telescope. So all of those are put together and we look at it again across the spectrum so we can get a better idea of what is happening here. And that neutron star is spinning 30 times a second. So think about how fast that has to be spinning. This is a thing the size of a city spinning 30 times a second. It takes that incredible density to keep it from tearing itself apart. And the energy from that pulsar then energizes the rest of the nebula and causes it to glow. Now, over time, the pulsar will slow down and start to lose energy, and eventually the nebula will dissipate out into space, leaving just the dead neutron star behind, which would make it then much harder to detect. They're easier to see when they are acting as pulsars and when we have this great nebula around them. Later on, wait millions of years, and we will not see pretty much anything except there will just be a lone neutron star sitting at the center of this image. So that was our picture of the day for August 24th of 2025. It was titled The Spinning Pulsar of the Crab Nebula. We'll be back again tomorrow for the next picture, previewed to be Stellar Surprise. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.